The compass, a need for adventure, a tool of explorers. A compass is used to give constant direction for the user. This allows a user to pinpoint themselves on a map. The most common type of compasses, magnetic compasses, constantly point at the Earth's magnetic north, not the North Pole, to provide a sense of direction to any lost hikers or adventurers. Th- This small magnetic tool is used in the early times by Chinese feng shui masters for worship, fortune telling, and geomancy. Later in the 12th century, the Europeans had caught up and had likely used them as a source of checking their route when such things as the sun, stars, and other visible landmarks could not be seen. But as a compass has gotten better built and more reliable, they became one of the most crucial tools for navigation, not just used as a backup. In modern times, despite the advance of GPS, compasses are still used in an airplane as a highly effective navigational tool.
Before we talk about compasses, let's talk about magnets, as they're important to understand before we get to compasses. Magnets can be explained with classical physics as well as quantum mechanics, but for grade 12 physics class, let's just leave it with classical physics for now. A magnetic or a magnet is something that emits a magnetic field that pushes in or pushes away other magnetic objects. We can leave it at that and most 4-year-olds would be satisfied, but we are physicists. In classical theory, it states that magnets emit magnetic fields, which are clouds of energy that push or pull away. Because of the way that it acts upon other objects, we call these magnetic fields vector fields, which describe the magnetic influences of the clouds of energy and are denoted by an arrow pointing in the direction in which it acts. Magnets have a positive and negative end. Positive to positive repel each other, while negative to positive attract. This is the law of magnetic poles. Now, a compass is a magnet that is positively charged, attracted to the Earth's north pole. How can the Earth be a magnet? Let's go one level deeper into the Earth. We can see that the Earth's liquid outer core constantly moving around from the rotation of the Earth. These convection currents actually cause the molten metal to act like a magnet. The negative end of the Earth's magnetic field is the north, which is what the compass is attracted to. However, these convection currents do not create a perfect north, as most compasses actually point to the north of Canada and not the actual North Pole. We call the actual North Pole true north, while we call what the compass needle points to as the magnetic north. Compasses are also really good at giving us angles, which can help us understand parts of kinematic vectors. A question that is quite common: is north 45 degrees east the same as south 45 degrees west? Although they are the same direction, they mean different things. North 45 degrees east means that you are headed from the north and going 45 degrees east. South 45 degrees west means that you're headed from the south and going 45 degrees west. To illustrate the difference, suppose we are on a boat and we're headed to the North Pole to see some penguins. There's a sudden detour. Would you rather head 45 degrees east or south 45 degrees west? The first option would make more sense, as you are already north and just need to slightly move your boat a little east. The second option suggests completely reversing the direction of the boat and then going west from there. Using the compass, many sailors started using the currents to their advantage. They could do this a lot more easily with the compass and intuition to find the direction the wave was headed. A simple question with vectors is if you are going north from point A to point B. Is it better to go with the current, in a straight line, or against the current?
Or straight.
And when I mean better, what is the quickest way to get from point A to point B? Many sailors realize that it's better to go with the current. This is because the diagonal vector that the boat goes with means that it has two vectors that make up it. The Pythagorean theorem states that the hypotenuse squared is proportional to the other lengths squared. This means that when you head in the diagonal with the current, you are adding the speed of the current to your total speed. This means that you can get from point A to point B a lot faster if you go with the current than the other two options.
Compasses played a huge part in advancing trade and economics. Before compasses, sailors were not able to make it too far out from land due to the fear of not being able to make it back in case they met a storm that could set them completely off course. But compasses changed the game. With compasses, sailors were able to reroute themselves to the route they had chosen, even when natural compasses like the sun or the stars were not available to the human eye. This allowed sailors to be able to go out and explore new lands and resources. Compasses also greatly increased the efficiency of trading overseas. as now the sailors will now have a faster and more reliable way of making it to their destination. This revolutionary tool also allowed for far more accurate maps. Medieval choreographers could look at the compass, walk a set amount of distance, and record how much directions had changed. This led to the creation of far more detailed maps than ever.